Hi everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. For this episode, our lesson is about the sum of the interior angles of a polygon. Just a brief recall, polygons have many angles. In our previous episode, I've mentioned that polygons are made up of triangles. We will use that concept in finding the sum of the interior angles of a polygon. We have here this chart, and using this chart, we will find out the pattern on how to find the sum of the interior angles of a polygon. In the first row of this chart are the different polygons. Second row is the number of triangles that can be created in that polygon. And the third row is the sum of the interior angles of the polygon. Okay, to find the number of triangles, we have to draw diagonal. So for foregon, to draw diagonal, this is from one vertex to non-adjacent vertex. So this is the diagonal of this foregon. And by drawing this diagonal, we created two triangles. So there are two triangles for foregon. Okay, what about for fivegon? How many triangles can be created in a fivegon? So draw diagonals, and there are three triangles. For sixgon, okay, let's draw diagonals and let's find out how many triangles are created. So we have here 1, 2, 3, 4. So there are 4 triangles. Okay, now notice the pattern. For foregon, there are 2 triangles. So this is 4 minus 2. For fivegon, 5 minus 2. So there are 3 triangles. Sixgon, 6 minus 2. So there are 4 triangles. Okay, what about if we have n-gon? Okay, n here is the number of angles of that polygon. So for n-gon, this is n minus 2. Okay, but why minus 2? Remember, to find the number of diagonals, it's n minus 3. Okay, minus 3 here because we need to subtract, okay, the vertex itself and the two adjacent sides. That's why it's n minus 3. But for number of triangles, since triangle is a closed figure, this is actually plus 1. So this is n minus 3 plus 1. So n minus 3 plus 1, that's n minus 2. So to find the number of triangles, the number of angles minus 2. Okay, now that we know the number of triangles of these polygons, we can now find the sum of the interior angles of these polygons. Okay, we know that one triangle, or the sum of the interior angles of a triangle, is 180 degrees. So 180 degrees times the number of triangles. For foregon, there are 2 triangles. So 180 times 2, then the sum of the interior angles of a foregon is equal to 360 degrees. Okay, what about for fivegon? One triangle is 180 degrees and there are 3 triangles. So 180 degrees times 3. Then this is equal to, okay, 540 degrees. For sixgon, okay, so 180 degrees times 4 triangles. 180 times 4, then this is equal to 720 degrees. Okay, now, what about for n-gon? So, for one triangle, 180 degrees, okay, times the number of triangles. So, this is times n minus 2. Okay, in summary, let's take a look at this figure. The number of diagonals that can be drawn from one vertex of an n-gon. Okay, number of diagonals, so it's the number of vertices, sides, or angles of the polygon minus 3. Okay, in this figure, we have here 1, 2, 3, and since polygons have many sides, vertices, or angles, this is, and so on and so forth. Okay, these dots here represent that a polygon have many sides, angles, or vertices. So, n minus 3 for the number of diagonals. Okay, for the number of triangles formed when diagonals are drawn from one vertex of an n-gon. So this is n minus 2. So by drawing these diagonals, in this figure we created, okay, 1, 2, 3. So n minus 2. So the number of triangles is n minus 2. And then, for the sum of the interior angles of an n-gon, okay, since one triangle or the sum of the interior angles of a triangle is 180 degrees, so it's 180 degrees times the number of triangles. So this is times n minus 2. So 180 times n minus 2. Okay, this time, let's answer this concept check question. When diagonal is drawn from one vertex of a heptagon, so this is our heptagon, it is divided into 7 minus 2. So that's equal to 5 triangles. So these are the diagonals drawn from one vertex of this heptagon. So by drawing these diagonals, we created 1, 2, 3, 4, 5 triangles. So n minus 2. So there are 5 triangles. Since the sum of the interior angles of triangle is 180 degrees, then the sum of the interior angles of the heptagon is, so this is 180 degrees, okay, times 5. And this is equal to 900 degrees. Okay, this time, let's answer this simple activity. Okay, answer the following questions. The first one is, find the sum of the interior angles of a dodecagon. Okay, dodecagon or 12-gon. So that means there are 12 angles in this polygon. So to find the sum of the interior angles of a dodecagon, one triangle is equal to 180 degrees. Okay, 180 degrees times the number of triangles in that polygon. So it's going to be n minus 2. So 180 degrees times, it's 12 minus 2. So 180 degrees times 10. And this is equal to 1,800. So the sum of the interior angles of a dodecagon is 1,800 degrees. Okay, what about number 2? What polygon has a sum of the interior angles of 3,600 degrees? So this polygon has a sum of the interior angles, which is 3,600 degrees. So we are looking for that polygon. So one triangle is 180 degrees. 180 degrees times the number of triangles, which is n minus 2. And this is equal to 3,600. Okay, to simplify, we divide both sides by 180. So this will be simplified. So we only have n minus 2. Okay, n minus 2 is equal to 3,600 divided by 180. So we will simplify. So 360 divided by 18. This is equal to 20. So n is equal to 20, then move this negative 2 on the other side, so this is plus 2. So we have here n is equal to 22. So this polygon has 22 angles.